So first, for the first equation,
Yeah, which one?
I'll,
Want to do
I'll
perimeter?
do the the 2L, like
Yes.
L for length,
To width?
plus 2W
Uh-huh.
equals 54.
Very good. Okay. Yeah, I would do that first. What about the next one?
And next one, I'll do L equals 2W minus 9.
2W. Yeah, very good. Minus 9. Yeah. 9 less than twice. Very good. Yeah, you okay? Now put it in the back. 9 less than. Put it in the back. Yeah. That's it.
Yeah.
Okay. Now I know you can do this. I want to actually now move on. I know we keep doing this, but just in case there's something fancy, let's look at 10. Is that okay?
Yeah.
We'll come back. We'll come back for it. Yeah. So what do you think about number 10? All right.
Uh,
Two two times a number plus three times another equals 13. All right. What do you think? The sum of the two numbers is 7.
I'll do the first number. It could be X,
X, first number. Or the first number. Y,
and
the
then the
second
second
number.
number.
Yeah, let's do
Yeah.
that. Second number. Yeah. Let's
So
define them.
yeah. So then I would do 2X
Okay.
plus 3Y
Mm-hmm.
equals 13,
Yeah. Okay.
and
And
then X plus Y equals 7.
that's it. Okay, we'll come back for this. All right, now, yeah, that's why I want to look ahead. It seems like they're going to have more, especially on paper. There seem to be more challenging stuff coming, like right now. 11. The sum of two numbers is 28, and their difference, oh, it's not that bad in this one. It's 4. Okay, what do you think?
The first number is X, and the second number is Y.
I know this is like redundant, but I think your teacher wanted to be defined, right? Always. First
Yeah.
number, Y is second number again.
And then I'll do X plus Y equals 28.
Okay.
Then X minus Y equals 4.
Good. And would you agree you would do elimination or addition method, right? Add them straight down to get rid of the
Yeah,
y?
I'll probably
Yeah,
do addition.
very good. Yeah. Okay, what about 12? And in Natasha's candy shop, chocolate, which sells for $4 a kilogram, is mixed with nuts, which are sold for $2.50 a kilogram. Chocolate and nuts are combined to form a chocolate nut candy, which sells for $3.50 a kilogram. How much? How much of each are used to make 30 kilograms of mixture? Okay, it seems a little fancy, but it's not that fancy yet to me. What do you think?
So our teacher taught us a method to deal with like these mixture problems.
Yes, there's a method. There's something to it. Remember, you've done this before too, right? Remember?
Yeah, I remember doing this.
Yeah. But wait, what do you think? Do shall we declare the variable first? What do you think?
Yeah, we can declare the variable.
What do you would you what do you want to call the variables? Do you want to do x and y? Do you want to do like the c and the n? I don't know, c for chocolate, n for nuts. Up to you. If you like to be seeing everything generic looking, because like that's like the math, you can keep x and y. It's up to you.
I'll do the like the C
Okay.
and N.
For so we do C equals the amount AMT of chocolate in kilograms. If you want, yeah, later on, sometimes they really want to make you specify, you know, unit and everything too. Chocolate, choco in kg in kilograms, and then N also lowercase that amount of nuts in kg in kilograms. It's up to you. You may just say amount of chocolate, amount of nuts. You don't have to put in kilograms because when you solve, you have to put the units anyway. The kg in the back at the end on the back. All right. What do you think about this one? Now, there's a logical reason why your teacher was saying, or you have to do it like that with the mixture problem, but it's easier than the one you were doing before, and you'll see why. It's easier than the one you were doing before. You'll see why. But want to give it a shot first, then I'll show you. Then we'll see.
So our teachers taught us a way to like make a graph.
Like a table, like a little chart.
Yeah, like a chart
Okay.
where I think it was like kilogram. Like on the very top, it would be like kilogram times like dollars per kilogram, and
Um,
then
I'll let you do it. Like I don't know. Yeah, I don't know. I'll let you do it, but I'm okay without. But I'll let you do it for the sake that you're remembering it. That you can recall how to set up the equations. So go for it if you want. But I'm trying to think it. I think I can do it, but I think I can do it. Let me see. kg, and I do want a kg for one column, and the other one is cost. Is that what you mean? Like the cost? Is that right?
yeah, but then there's like another column for like the total cost.
Okay. Okay. Yes. This. Okay. I remember the total. Got it. Got it. Total. Okay. Okay. But I don't know how many rows are we gonna. How many rows do we need?
We need three for the chocolate, the nuts, and then the mixture.
Okay. All right. So I assume you want to do. I don't know. This is going to be for the chocolate, and then this for the nut. Is that right?
Yeah,
So this is going to be. That means this will be x. This will be not x, c, and this will be n. And if you, I guess the total also down here, right? Something like that. Total.
yeah,
So
that would be like the mix.
next that be what is it? 30.
So there,
Is that right?
yeah, it would be 30,
Okay. Now the
and
cost
then the next column it would be the cost per kilogram.
be okay. That'd be
So
4 for the chocolate.
yeah, before, and then for the nuts,
So 2.5,
two,
250, like that.
yeah, and then for the mixture, it would be 350.
350. It says it right there, right? 350
Yeah,
for the mixture. Okay, so forth. All right, I like it. Okay, I remember it now. I remember it. And then when you actually put it together, the equation for the total here, it should be 4c, right? 4c times,
yeah, for
and this will be 2.5 or 2.50 n, right?
yeah,
And then
and
this will be 3.5 times 30 or 30 times 3.5. Is that right?
yeah,
Okay, I got it. Now, how would you write the equations? I'll bet you know it. I think we could take out this column now, right? Something like that.
yeah.
So, okay, tell
So
me.
I would write like below this or like yeah, on the side. All right.
are you still with the table? Are you still with the chart here?
No, not really.
Okay, wait.
You're just like
If you want, you can make an extra row here, but might as well set up the equation, right? You can probably do that
yeah,
now. All right.
yeah.
Okay. What do you
So
think?
then I think it's like 4c plus 2.5 n.
Uh huh. 0.50 n. I'll do the 0.50 n. Or yeah, let's make it look like money. If it's money involved, is that okay? Put 550. Or if you don't want to multiply the equation by 100, then we'll keep 2.5. What do you think? It's up to you. I'm good either way. What do you think?
We could keep 2.5
Okay, let's do 2.5 n equals what?
equals
3.5,
like yeah
times
times 30.
30?
So like
Yes. Okay, right there. And what about the second equation?
I don't know if there's a second equation like involved with this.
Okay, the second equation will have to do with the quantity, the amount. This column right here. See that?
Oh
Yeah,
yeah.
yeah, that's it.
Yeah, I
Yeah.
think it's
Yeah, I
yeah.
know because like you have a bunch of costs, like price for whatever, tons of them written in here. But that means there's still amount. They're talking about the amount in quantity, like 30 kilograms anyway. So we have to have that. So what do you think? So it should be C plus N equals 30. Am I right? That's
Yeah.
it. That will be it. Yeah, you could have also written the C plus N equals 30 first if you want, but that's it. But I know why you wrote this one first because you made the table just for it. The first equation. That's it.
Yeah.
I'm pretty sure this looks good to me. All right, now let's look at the number 13. I know you can solve it however you like. Okay. Yeah, I know you can do this. All right, let's look at 13. You okay? You okay? The equation? Yeah.
Yeah.
We'll come back to solve it. I'm sure no problem. Right. 13. Danny invested $11,000. Part of his money is invested in a bond, which yield 8%, and the remainder is invested in bonds, another one, which yield 10%. So you got an 8% bond and 10% bond. His total annual income from these bonds is 1,020. Find the amount he invested in each kind of bond. Now, I know that you can do a table on this, but to me, this is actually a little simpler than number 12 because just like, right? So do you want to do it
Mhm.
without? Yeah, let's do it without.
Yeah, I think I can do it without the table.
Yeah. What do you think? Let's go for it. What variable do you want to assign?
We could do like the 8% would be X.
Okay, good. X for the 8% bond.
Yeah. And then for the 10% it could be Y.
Okay, good. Y for 10% bond. Now, obviously, it has to do with the amount. You might want to put the what amount in front of each one. Amount, 8%, or be on the back and parenthesize it. However, but yeah, it's amount. Some teachers don't care for it. Just label 8%, 10%. Sometimes just 8%, 10%, just like that. Nothing else. But okay, now how would you set it up?
So I would set it up like, wait, let me think. Okay. I would do X plus Y equals 11,000.
Yep, that's it. Yeah, you got this. That's how much you're trying. That you have two portions that you can split them for 8% and 10% bond out of this 11,000. Yep, that's why. Okay, what about the second one?
And the second one, like I would change the percents into
Mm-hmm.
decimal.
You have to. You don't want to use that percent. So it'd be zero point 0.1. I assume X, right? And do zero
Yeah.
point zero
Yep.
0.08 like that, right?
Oh, we put X
Oh,
for the 8%.
sorry. You're right. 0.08 x. You're right. Good job. Yeah. And 0.10. It's up to you on that O in the back. I would do it because I did a oh 0.08 here, two decimal places, and then y equals what? The the bond amount, right?
One,
Yeah,
yeah,
the 1020.
1,020.
Okay, that's that. I think you okay, but let's finish setting up everything. That looks good to me. Let's finish up everything and then we'll come back and look at the work. What do you think about number 14 here? Trisha and Byron are washing and vacuuming cars to raise money for a class trip. Trisha raised $38 washing 5 cars, vacuuming 4 cars. Okay, now it's getting a little fancy here, but I think you're okay. Byron raised $28 by washing 4 cars and vacuuming 2 cars. Find the amount. The key here is this: find the amount they charged to watch a vacuum, to wash and vacuum a car. So that this time when you define the variables, it will be in the in dollars or the cost. Is that okay? So,
Yeah.
all right, what do you think? What shall we do? Let what?
So first I'll start with like defining the variable.
Yes, let's define it. Let what variable do you want x and y? Do you want like now careful, I would not recommend you use their names because this has to do with your finding the cost, the charged for washing and vacuuming, right? So
Yeah.
so what do you think?
I could do X and Y.
Okay, let x
So
be the amount for washing
yeah.
in dollars and amount dollars for washing. I put like if you want the unit to be somewhere written, I probably print size with dollar sign or something, or in dollars or whatever. I put dollar here up here amount. Y be amount dollar amount. AMT like no like messy here for 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 vacuuming. Okay, something like that.
Yeah.
All right,
So
now yeah,
for the
how would you
equation,
how do we set it? So instead of like the cost timing the amount cost timing the amount, I'm sorry, like the quantity or whatever, like you always have the like the percent or dollars in the front. You see like this thing here in front. Now it has to do with the what do you call it, the 4 cars, 2 cars, right? The cars. Yeah,
yeah.
I think okay, okay, let's go for it. What do you want? How we want to write it?
So I would write it like 5x
Okay,
plus 4y
plus 4y.
equals 38.
Yep, that looks good to me. So yeah, the cost you're gonna try to find by doing 5 cars, and the cost for washing and the and the vacuuming for 4 cars. Is that okay? Yeah, this time it has to do with the number of cars being the coefficient, the number in front. Yeah, it looks good to me. It's a little weird because you got so used to doing like the the a cost in the front. But anyway, what about the second equation?
And then the second equation
So
I would do
Byron.
4 4x
Hmm.
plus 2y
Yep.
equals 28.
Yep. Yeah, you got it. Yeah, you got everything, dude. Here. All right. Just be mindful. That's why there's a reason why you actually write or define the variable so that you get your units correctly. Some of them, I kind of like last time, I forgot, I got them, I butchered one of them, I think, at least. But yeah, that's why you want to do this. So this time for this particular problem, number 14, you're solving for the cost, not kilograms, not 5 marbles, whatever, not marble, number of coins. This time it's the cost you're getting. So it looks just like that. It's just like inversed or inverted in a way, whatever that word is. But that's it. But the whole equation is still in dollars, by the way. Oh, I don't know why it's two. I think when I touch it, it's like undo. Sometimes I do. Yeah, it's 28. Yeah, 20, 38. Yeah, 28. Yeah. Uh, so just be aware when you solve, you got to put your dollar sign or write the word dollars behind the answers, the X or Y, whatever you got for the X and Y. It looks good to me, dude. I want to say something about the bond here. Where's that? This here. When you get your answer, whatever X is, you should write it exactly like the way you define the variable. Let's pretend I'm making this up. If you're 8% X, right, you get, I don't know, let me see the total. It's coming from 11,000. Pretend it's like 5,900, right? You would say 5,900 for the 8% bond. You should specify that. Is that okay? Because
Yeah.
how else would you write it, right? You have to specify what kind of bond. Is 8% bond or 10% bond? Just write 8% bond, 5,900. I'm making this up. If that were the answer, because you can't just say $5,800 that and equals X. You don't know what that is, right? Which one are you? Which one is it? Is it which bond is it? That's why you have to specify. So be careful with this one. I have teacher actually mentioning that student did not label the answer correctly for this type of problem, number 13, with the bond, with the percent type of problems.
Yeah.
So make sure you specify which is it. Is it 10 or 8% once you solve for it? Even though you label it up here, you should still state it in the final answer. All right, I think you're good, but let me look back here. Okay, I know we can solve them, but let me have a look at your graphs quickly. Can I ask, did you do this in class or did you do this number 6 and number 7?
I did this in class.
Like together in class, right?
Well, not like with the teacher,
Oh,
but
okay.
I did it like on my own, but it was in the classroom.
I
So.
see. Okay, I like you to watch me do it. There's a reason because you may there's two ways of doing it. There's a clean way and a messier way. I know like you did this, it's not too bad, but it can get complicated maybe soon. What do you mean by that? Right. Let me give you an example. You may get a third equation and a fourth equation. You'd be like, "Are you kidding?" Graphing, yes, but it's not. You're not going to solve for them. You're going to solve it. You're only going to graph them. The graph will look something like this. If you ever wonder, it will look something like this, like this. Like you have four equations cut up, and then you have to shade where it's actually kind of no kidding. So this will be one of the one of the two equation will be the axis. So you have to kind of shade above it. They'll tell you that like greater than y, greater than x. I'm sorry, y greater than some number, x greater than some number. Normally zero for both. But right now, I want to see if you're okay. So let me look at it quickly. So let me look at this. Okay, let me see. You did this in class, but let me check it. So you grab x greater than -1, x greater than -1. By the way, it's already incorrect. Number 6 is not correct, dude. Let me
Um,
do it. Yeah. I may have to look at number 7 carefully. I think your 7 is good, but let me see. Okay, watch. Number
yeah,
11. Number 6. When you grab x greater than -1, you will grab, remember how like when you did the number line? If we were to grab on the number line, right? You'll be doing -1, you'll be open dot here, and then you shade that way. Do you remember this?
yeah,
You, you sure? If and only if the variable is on the left side, you can shade exactly where the arrow is pointing. On the left side, when the variable x, y, or z, whatever is on the left side, you can automatically shade it according to based off the inequalities, like pointing. So it's pointing that way, you can shade that way exactly. So here it is. The reason why this is incorrect is because now this is 2D now. If it were 2D, then you'll be shading everything that way. See that? So
yeah,
if you look here, your -1 is here. Therefore, if you were shading the other way, it will look like this. if you were just to do the first equation, if that if it's on xy plane, you'll be shading that whole thing and you're done. Let's just say this is the first equation. See it? So that's why it cannot be located on this side of it. I know that you're looking for the overlapping, so it's not there because it has to be somewhere over here or up there. But let's see. Okay, right now. So if you wonder how some textbook do it, but it's a messy way. Because they have colors, right? They can color code it. So they go like this. But since this, I'm doing it by hand. And first of all, you did good here. You have to dash it. First of all, you have to dash that x equals -1 because there's no bar underneath it. So you okay with that, right, Alex? Okay, now
Yeah.
if you were to shade it, show all the work, it would look like this. Now there's a way you can do this, like pretty cool way. Now this is actually very dark, so let me go in, man. Let me go ahead and fine. Let me go ahead and make my ink smaller. So here we go. You can do a perpendicular line to your dashed line. I don't know if you see what I'm saying here. So I'm going to shade it like this, all of it. Now, I'm not going to keep all of this right now, but I want to show it to you. So it's going like this, like with the arrow like that. Okay. Now, notice I did this perpendicular to, like perpendicular to that line, or the dashed line. Why am I doing that? Well, you'll see. It's a pretty cool method. Now, I'm done with my first equation, my first inequality. What about my second one? Here we go. Let's locate. Your y is less than -3. So locate -3 for y. It's right here. So you can draw the equation. It's solid, right? It's right here. Right here. There it is. And then you have to shade below it. This time you have to shade below it because it says less than. So you shade everything below it. So here, I'm showing all the work. So therefore, you see the mesh now, the overlapping. The answer is over here. The rectangle over here. So I know you see it even before I even did all of this. From what I was saying about the arrow pointing the other way. So there it is, the answer. So, but if you were to show all the work, it would look just like this with all things shading, looking messy, and the only thing you keep would be here. You can bubble it, but look, what if you do it the clean way? You want to see it? But you have to use your imagination a little bit. The clean way looks like this. First, you still grab the lines, the dashed line and the solid line. So take a look. So you'll be dashing this line. Let me go back and do it again, okay? So I'm going to shade everywhere on this side of -1, but if you want to you don't want to shade everything. So some people do the arrow thing. I know that some teachers do this, like just do a little arrow, like don't go too far, the arrow pointing that way, arrow pointing that way. Some people don't do that many arrows. They just do 1, 2, and maybe 3. Okay, so you know it's going on that side. And then the y, okay, your y is -3. Here's your y equation. Then it's going down. So you do arrow here, and arrow here. Then you use your imagination where they're going to overlap. That's it. Is that okay? So there it is. So it's going to overlap right here. And then you can shape them one time. It's up to you if you could imagine it. But the arrow kind of help you, hey, it's this direction, okay, over here, down this direction, all that. You know what I mean? That's
Yeah.
it.
Yeah.
So that's the clean way. Now let me check this. I think you did this one great, but yeah, I would definitely solve for the y. Let me have a look. It looks good. Okay, let me go have a look. Up 1, down 2, run 1. Okay, good. It's negative. You good with this? And it's solid. Yeah. Okay. This equation is perfect. All right. What about the graphing? Right. Again, have a look, okay? If you have y already solved on the left side, you are now allowed. This is pretty cool method. You're allowed. It says greater than. You can shade now, but you got to be careful. When you sketch this, pretend you didn't do anything else. You have to use it. Imagine there's a car parking here. It's very steep, like San Francisco, right there. You cannot draw below it if you want to. This is a little trick that they have out there, even online. So try to draw a car on the line, on both lines, and make sure they don't fall under. Okay, make sure that it's still kind of like possible in a slanted slope. Okay, then if you have the y solved and the arrow is pointing greater than, it means you shade above the car. Like you imagine you shade above the car. So there it is. Now again, if you want to do the clean way, Therefore, you just go ahead and do the arrow, just like a little arrow, like here, a short arrow here, maybe one right here, and maybe one right there. So it's going that way for the first inequality. The second one, let me see, you solve for it. Let me check here. So it would be y x plus 2, but it's this way, but then you flip. Good job by with flipping. Yeah, sometimes you can just do everything mentally. Yep, I agree. Be x plus 2. Double checking here. Yep, very good. Very good. Okay, now, all right. Then this one is also incorrect. Wait,
Oh no.
no. I'm wrong. You're right. Okay. So if you have y solved on the left side, sorry, yeah, you're right. You're right. You got this one right. If you got the y to be on the left side, again, reset like a computer. You never seen this chord drawn. You never seen this slope drawn, and then you grab this right here, the second inequality, just at least the line. You did it right there. So you grab that. That means you want to draw a car again. That so it doesn't fall under. Okay, so the car has to be like above right here, like right here or whatever, right? So there's your car. And then again, based on the way it's set to shade, it says less than. You shade this time. You shade below the car. Below the car. Here it is, below the car. Therefore, if you do the arrow thing, it will overlap right here. So you got it right. Is that okay? You see that? Yeah. I think you know it perfectly, even for number 6. It's just that you did a little boo-boo there for number 6. But yeah, if you got 7 right, that means you know number 6 perfectly. Yeah, just be careful on that one. When they're like straight lines, like vertical and horizontal line, that could be a little tricky. Yeah, you got it, dude. You got everything. But do you see like a little trick there that I did? Like, hey, you draw the car, it's like above or below the car. Now, why do you need the car? Because sometimes you don't know above where it is, above or below where it is. So if you have a point of reference, like a person or a car, you talk that way, above, below, above the car, below the car. You know what I mean? Now, this is exists. Okay, this thing, I didn't make this up. It's actually a person or something. I think I used the car, but there is this thing online that you can look up, or they should have it by now. This thing has existed before, like even internet, I think. Anyway, all right. I got to check that. I think you got it right. All right, all right. Look at it. Hey, one thing you may not think it's that big of a deal. Your teacher might mark you this answer, even though you got them right. Do you want to tell me why? There's a possibility that your teacher may not accept that. Do you want to tell me why? What's
Uh,
missing? Well, let me say this. I believe you know when you solve, right? Yeah, you probably got your x being 2 and your y being 3. You can still keep it like that, right? Out there. But if you write it in a coordinate form, do you think this is correct? I think you meant like x comma y, right? Is that what you mean?
yeah.
Okay. Believe it or not, you can't actually leave your answer like that. And I believe your teacher will mark you like 95%, 90% sure. Unless your teacher is really, really nice, very lenient. Now, tell me why this is not acceptable, if you know it.
Uh,
You need parentheses. Remember? Yeah.
oh.
Yeah, your teacher will mark you. It does not notate the coordinate form of the graph. Like, yeah, you need the parentheses. So do put the parentheses there, because does not mean it's x comma y at all. The 2 comma 3. Yeah, because the punctuation thing relating to graph, you know that, right? Like it's always been that way. So yeah, I'm pointing that out. I'm making I'm emphasizing the punctuation now. Okay, yeah, if you are gonna write it in x comma form, parenthesize them, because that's the coordinate punctuation notation. All right. Based on what I can tell, I think you got it down, dude. Pretty sure. I'm glad we went over the setup of the problems, because like this one, like the table one. Yeah, I think it's good. I could have done it without it, but I think this is so good. I realizing that. I think this is how they always want it, like for the beginners, like learning to do number 12, the one that looks like number 12.
Yeah.
But you did worse than these ones without the table. Remember? Yeah, you did it without the table. A bunch of them that kind of like this number 12, but yeah, more challenging than 12 though. Mixture problems. Remember? Yeah, the algebra ones. All right. Oh, with the same variable, right? With the one variable. Yeah, that's right. That's right. I remember. All right, I'll let you finish the rest because I know you can.
Yeah.
Unless you have something else you want to ask me, but I think you're good, right, Alex? Yeah.
Yeah. Yeah.
Okay. Okay. Yeah. Just and you're sure number six is good now, right? Greater than. Yeah. Anything greater than one, like 0, 1, 2, 3, 4, 5, greater than -1. That's why you're shading in that direction. But use the arrow. The variable must be on the left side. It's like kind of thing that you always try to get for solve in the beginning, if not already. All right. All right. We'll call it. I know you